Hi, today we talk about calibration of an instrumentation device. First, we should know what's a calibration. According to the ISA dictionary, calibration means a test during which non-value of measure are applied to the transducer and the corresponding output reading are recorded under specified condition. Simply, calibration is to make sure the reward variable measurement matching the standard electric and pneumatic signal. For example, temperature sensor. If your detector is temperature, if you have a range from 300 sources to the 500 sources, you should this temperature signal transmit to the electric signal 4 to 20 MA. Calibration just do this job, just how to match. Okay, in classical instrumentation just analog device. Calibration and range are modified at the same time. That means if you do analog device, you should adjustment 0 span. At the same time, you just do span modifier, or first do 0 modifier, then you do span modifier. But in modern instrumentation, smart digital device, calibration and range are modified separately. That means if you do calibration, just do calibration. If rearrange something, you just separate. Okay. The characteristic of calibration is accuracy. The accuracy means the ratio of the error to the full-scaled output, or the ratio of the error to the output, expressed in percent span or percent reading. Error equal measure minus standard. Accuracy is a percentage equal error divided span times the 100. Tolerance means everybody don't understand this tolerance. Yeah, for example, 0 to 300 psi tolerance, positive, negative 2 psi. But we should know the output tolerance. If your 4 to 20 MI is the output, you should know is the output tolerance. How to calculate this one is 2 divided 3 times 16. So this is output tolerance equal 0.10 MA. Resolution. Resolution means the digital value represented by 1 bit are displayed in digital measure. For example, if 1 bit measure represents 1 million ohm, then resolution is 1 million ohm. Precision, for example, everybody know, yeah, precision. For example, pi is equal 3.14159 or equal 3.14, but 3.14159 is more precise value of 3.14. Repeatability means the close of agreement among a number of consecutive measurements performed under the same operating condition. Long-term or short-term repeatability are both important. Clarify. Accuracy is how close the instrumentation reflects its input. Repeatability is a term given to an instrumentation that reflect the same output signal from a constant input signal. Is accurate means is that every time is accurate very high means that every time is output is the date is close the you want to measure is the date. For example, you want to make sure is the output is 3.5 psi, but your every time your calibration, your testing is the data is 3.49, 3.48, 3.47 is very more accurate than 3.25 to the 3.5. So is repeatability is every time all this close every time. If you're testing, every time is close, that's called repeatability. Repeatability is different accuracy. Accuracy is much more repeatability. Maybe is repeatability is more, but maybe it's not accuracy. Okay. What's the standard electric and pneumatic signal? Electronic is the 4 to 20 mA DC, 0 to 20 mA DC, 0 to 10 volt DC. Pneumatic 315 psi. 4 to 20 mA DC is very popular in the hard communication. 0 to 20 mA and 0 to 10 VDC is very popular in the PLC output and log output. What's different between transducer and transmitter? Transducer, a device that can change one form of energy to another. In industrial instrumentation, a transducer converts one standard instrumentation signal into another standard instrumentation signal. For example, thermocouple convert temperature into a voltage. A to P and P to P device is called transducer. Transducer is in general is just one form energy convert to another kind of form energy. But many transducers are grouped under the heading of sensor. Sensor is a transducer. But what's a transmitter? Transmitter is a device translates the signal into a standard instrumentation signal, such as 4 to 20 mA or 3 to 15 psi. So, most time we use transmitter to convert the physical signal, is a transducer signal, to the electrical signal. Okay? Then send to controller. Common terms. Calibration range. Calibration range is every time if you do some process, your process controller, you have range. For example, level is the pressure, you have range. If you buy some instrumentation, if you shoot calibration, you should use this called calibration range. Calibration range is defined as the region between the limit within which a quantity is measured, received, or transmitted, expressed by LRV, URV. LRV means low range value. URV is up range value. So if you do calibration range, you should use zero band value. Okay. For example, is your measure pressure is 0 to 400 psi. Then LRV is 0, URV is 400. Okay, span is just equal URV minus LRV. This is called span. For this one, this example is span just 400. If your other example, if your range is 100 to the 500, okay, its range is LRV is 100, URV is 500, but the span is 500 minus 100, it's 400, okay, 400 psi. Before we talk the calibration range, but we should know is instrumentation range. Instrument range, every instrument, if you buy new one or use every time, they have the range. They have data sheet specification tell you what's the range. What you do? For example, in here, instrumentation range is 0 to 800 psi. On the output 4 to 20 mi. So never confuse the instrument range with the calibration range. They are two different things. We can use 0 to 800 psi instrument range, but we can calibration is the 0 to 800 psi range. We can calibration 0 to 400 psi range or 200 to 600 psi range, depends on your application. But if you do this one, you should think about the turn down. Okay, later we talk the turn down. So instrumentation range is refer to the capability of the instrumentation. So you don't confuse the calibration range and the instrumentation range. This is a mathematical equation of calibration. Calibration, we just linearity, okay? Linear, always linear. Here's linear, okay? His equation is y equal mx plus b. Y is output, x is input, m is the span, b is 0. Okay, here this is m, here's b, is 4 mm output, is 4 mm to 20 mm, is LRV. You can look, here is an input, LRV is 0 to 100 psi, is output, is LRV is 4 to 20 mm. Look. So zero adjustment is achieved by adding or subtracting some number. Span adjustment is achieved by multiply and dividing some number. Zero adjustment is typically like this one: bias force, mechanical offset, bias voltage. Span adjustment is the fulcrum position of a lever. If you adjust amplify the gain, spring rate, this is called span adjustment. Zero adjustment, span adjustment, this is the analog device or often zero screw and the span screw with adjustment. We can often use this one, but in the digital smart digital transmitter, we don't use this one, but we don't use the mechanical some stuff. Calibration error. Calibration is have zero shift, span shift, linearity shift, hysteresis error. Linearity error and hysteresis error. Hysteresis error is y equal mx plus b. Y is output, x input, m is span adjustment, 0 b is 0 adjustment. 0 cause 0 shift. This one is standard, okay? Linearity span standard. This different 0 here is here is different, okay? This called 0 shift. If you do look like this, you should have 0 trim calibration, okay? If you use analog device, you have to 0 modify adjustment and the span modify adjustment together. This called span shift. Span shift, look, this loop M is different. Every time is measured different, okay? This is called span shift. This span M slope is different. It's called span shift. This is called linearity. Yeah. Here, this effect 0 shift. This is span shift. This is always the input-output calibration with all the linearity, okay? Just the different pressure transmitter is a flow transmitter, different pressure flow transmitter, just not linearity. With calibration, just make sure his linearity, okay? This is not linearity. Not linearity is called linearity error. This one is standard, but here is testing every time is not good, so it's called effect of linearity. Is M not equal mx plus b. That's it, okay? This is called hysteresis error. Hysteresis error means if you're from beginning from LRV go to the URV, is testing is a little bit high or a little bit low than standard. But if you're up, go down, are still like this way. It's called hysteresis error. Hysteresis error just because the mechanics some trouble. So in the modern smart transmitter don't have this error, okay? Hysteresis error are almost always caused by mechanical friction on some moving element. In practice, most calibration just have not just one error. If you have any error at first, it have 0 error. It doesn't matter which error you have. Maybe you have a span error, linearity error, hysteresis error, but first is 0 error, is have trouble. So, in other words, it's extremely rare to find an instrumentation with a span, linearity, and hysteresis error does not have the 0 error. That is possible. Okay? Every time, if you have 0 error, span error, you can do calibration. But if you have linearity error, maybe something you should follow the is manual or the data sheet or something. If you fix, if you're not fix, you should return to the company. Okay. Is calibration we have 2 calibration. Is a bench calibration, a field calibration. Field calibration means that we do calibration in the side. We do not disconnect the transmitter. We just do connection the process line, still do something, But most time, if you field calibration, in the field calibration, we just do zero check, or if you can't do full calibration, because the source is the standard source is not standable. For example, if the press transmitter, if you do field calibration, you should have pneumatic source, but pneumatic source sometimes not standable. Okay. If a bench calibration means the procedure instrumentation is calibrated at the workshop bench. So if you do bench calibration, you can do fully calibration. Is a fully calibration, you can use zero span adjustment to everything. Okay. Here the instrument is the bench calibration is for sure is disconnected from the process. You bring the workshop. You do calibration, you should clean up, attack the shop, clean up, testing stand, connection testing stand. Okay. Damping adjustment. Damping means noisy. Yeah. Is the actual disturbance. The vast majority of modern process transmitter come equipped with the feature known as damping. Is damping just noisy? We have to reduce the noise in the transmitter. If you have to reduce the noise, is use the filter. Filter is simple, just use is a compress of resistor and capacitor. It's simple. But before damping look like this, up down, up down. If after damping looks like smooth, okay. Damping sometimes is very important. Okay. For example, before I do some positioner install, is always cut off line is shut down the transmitter. We check everything, we find is the signal is 4 to 20 mA signal, but he should have grounding line connection to the grounding. Okay, is cover, is all the metal cover should the grounding line. But his grounding line is free, is not connection, is disconnected. We just connect, everything is gone. Okay, no damping. No noisy. Everything is not after damping. So we just adjustment a little bit of damping. Okay. The key question is how much damping should be applied. If too much damping, excessive damping will cause the transmitter to underestimate the significance should suddenly process change. If no enough damping, just too much noise to reach the control system. So, if you have no damping, is always undamping signal, noise too much noisy. You don't know what's going on. The control system, you can't control everything. If you're too much damping, over damping signal, look like this way. But if you're emergency, suddenly some emergency signal coming, for example, pressure is emergency too high, he think this damping. He think this noisy. He forget sluggish response to any sudden change. That's not good. So we should, how much damping we should apply. Damping should be set to absolutely minimal during calibration. So the result of applying stimuli to the transmitter will be immediately seen by the technician. So you should have a little damping, not too much, not too slow, a little bit. Okay, minimal during calibration. Maybe you can reading the manual on that sheet. You can find the minimal damping. How much minimal damping? Okay. This one, instrumentation turn down. Most people don't use this one. Maybe some people don't understand what's mean. Turn down or call range down. Turn down is very important to choose the transmitter. Turn down equal maximal allowable span divided to minimal allowable span. This is called turn down. For example, pressure transmitter in the data sheet, he always told you maximal calibration range is 0 to 300 psi, but turn down is 20 to 1. So if your 20 to 1 is minimal span, should be 15. Maximum span should be 600 psi. What means this one? This one, if you choose the new transmitter, if you should use this one. Okay, the turn down ratio tell you how far you will be able to practice adjust your instrumentation range. For example, one process tank measure range 50 to 90 psi. His range is 40 psi. Okay, transmitter range 40 psi. But if your new transmitter come in, his max range is 0 to 1000 psi. Is turn down is 20 to 1. 0 to 1000 is a new transmitter, but your process measure is 5090 is in the 0 1000. Look like it's okay, yeah. But we should check his minimal range. This new transmitter is 1000 psi, maximum range is 0 to 1000 psi. Its span is maximum span is 1000. It turn down 20 to 1. So 1000 divided 20 equal 50 psi. So its transmitter miniature range is 50 psi. But the tank required transmitter range is 40 psi. So it's less than the minimal range transmitter. So what do you do? First, you have to change range to 50 psi. Go to the you're changing range to 50 psi. You're changing the range. Is before range is 40 psi. Now you have to change range 50 psi. So is LRV you should go down to 40. Okay, then that's in the 50. Its range is minimal range is 50 psi. It's 4 mi go to the 40 psi. If not accept this choice, you have to order new one. Okay, this one just the choice. If you don't have this one, you can't use this one. So the process measure range must be in the period between maximum span and the minimal span in the special device. That's important. Okay, every time you have a new transmitter coming, you should check this one. If you replace the transmitter, if you're not exactly, but just range is okay, but turn down different. Okay, everything should be checked. Okay, typical turn down ratio of various meter type. A thermal measure flow meter is 1000 to 1. An orifice plate is 3 to 1. A turbine meter is 10 to 1. Rotational position displacement meter is 80 to 1. diaphragm meter is 80 to 1. So this one just is some idea how to use what's the turn down is. As found, as left report. If you finished the calibration, you should write down report. What's report? Report should be like this. First, you should know what's mean as found, as left. As found, that means if you go to the site, you check is the site, you give your signal, you check what's going on. So this is a display should be as found. After calibration finished, you check again. This is called left that. After that, then you should calculation is error. What's mean error? Error equal measure output minus stand divided span equal or times the 100%. So that's called. For example, here is 16. This output is 4 to 20. Okay, its span is 16. This is called 16. Measure output is 3.99. The standard is 4. So 3.99 minus 4 divided 16 times 100%. So it's minus 0.0625% is error. Okay, that's it. This is the first time we talk about calibration. The basic idea is the next time we talk is how to calibration. Is the 5-point calibration on the smart transmitter calibration. Okay, thank you very much.